Let's take a look at an atom of helium. Here we can see both of helium's electrons, and these electrons don't like to stay in one place. They'll be moving all around like so. When these electrons are moving, can you see where these instantaneous dipoles are? If we stop the movement for a moment, we can imagine where the dipoles of the molecule are. These dipoles will be formed where the electrons are closer together in their movement. So here we can see that the negative charge will be located where the electrons are more towards one side, and then the opposite end of the atom will have a positive charge because there are no electrons. Now, what happens if we introduce a new atom of helium? From our knowledge in chemistry, we know that electrons repel each other. So when a new atom of helium comes, the electrons from helium atom 1 will repel the electrons from atom 2. And when these electrons from atom 2 are repelled, we can imagine how these dipoles will form. Now that both atoms have dipoles, how do these atoms become attracted to one another? Well, negatives will always react with positives, so the negative pole will want to come closer to this positive pole. When the two atoms are attracted to one another from their dipoles, we call this an intermolecular force. And so this was an example of how London dispersion forces work between two atoms.